G'day lads, we're just going to be expanding these 5 problems first this morning. So if you want to just go ahead and pause that video and just expand those out, that would be awesome. Alright, now that you've expanded those, I'll just go through those quickly and run you through the method. So we would have, if we expanded that, we'd have 3x plus 6. I've got 3 x's. If I was to do this out the whole way, remember, I'd have 3 lots of this thing. So I've got 3 x's and I've got 3 2's, and you know that 3 2's are 6. So there we have it, our expansion. If I was to expand this, I'd have 4x plus 4y. And if I was to expand this, I would have 12x take away 10 or plus negative 10. If I was to expand this thing, I'd have 3x times x, and that would be 3x squared plus 2x. Right, I've got 2 lots of x there. This one's a little trickier. I have 3 times x times 2 times x. So the 3 times 2 gives me 6, and the x times x gives me x squared. So I've got 6x squared in there. Take away 1 lot of 3x. Awesome. What we're wanting to look at today is the reverse of that problem, of that operation. So we call that factorization. We want to factorize these things here. So how do we go from 3x plus 6 back to x plus 2? So what we look for is what we call a common factor. So what is a common factor in 3x plus 6? Well, 3x, that's 2 factors, right? Which means the 2 things that multiply to give that product are 3 and x. Now the factors of 6 are 1 and 6, 2 and 3. And so what is the highest common factor of those 2 things? Well, it's 3, isn't it? So that means that I can take a 3 out of both of those things. So I'd be left with an x and I'll be left with a 2. So I'd have 3x plus 2. So you can see that what do I want to get out of both of those terms there. So let's have a look at what that might look like for these. So what is the highest common factor of 4x and 4y? Well, x and y don't have a common factor, they're different variables. But what I do have is I have a common factor of 4. So if I pull a 4 out of both of those terms, I would be left with x on the inside plus y on the inside. So those are the same thing. So factorize, I've got this now into one factor, and that whole bracket is my other factor. Because remember, factors multiply, and we've got a multiplier in there. So what we've done is we've taken a sum of 2 products, we've factorized, which means we've turned it into 2 factors. Think about it as the opposite of expanding. Now, the highest common factor of 12 and 10 is 2. So a 2 can come out of both of those. So what would I be left with? Well, I'd be left with a 6 and an x, right? I've got an x there. Take away 5. And if you just want to get into the habit of checking that you've taken the most out as possible, because sometimes you might make a mistake there and take out something which isn't the highest common factor. Alright, now it's getting a little trickier, right? We want to factorize out the highest common factor. So 3x squared, the factors are 3 times x plus 2 times x. So now what I want to do is I want to take out the highest common factor. Well, you'll see that I have an x in both of those, and 2 and 3 don't have a highest common factor. So I'm taking an x, pulling an x out of both of these terms. So if I take an x out of this, what's left? Well, it's 3 times x. Right, there's my 3x squared if I expanded. If I was taking an x out of that, I'd just be left with a 2. You guys could try this one now. And you'll see that if I had a common factor here, I'd have 6 is 3 times 2 times x, take away 3 times x. So a common factor is 3 and x. So I'm going to take a 3x out. What's going to be left on the inside? Well, if I took a 3x out, I'm left with a 2x on the inside. And if I took a 3 and an x out, well, remember that's times by always a 1. You wouldn't write 0, that would be minus 1. And that should be the 4 equations you had to expand to start with. And it is. There we have it. That is factorization. What is a common factor that can come out of all of those terms? Now it's really nice. It's a really nice way of turning addition, subtraction into multiplication, isn't it? And later on in linear algebra, and especially quadratics, you'll see why that is so important. So why don't you guys try these problems here and try and factorize those. So you guys can pause that there and give it a shot. So what I want to take out of both of these is an x, isn't it? That is the highest common factor out of both of those terms. So it's going to be x on the outside, and I have 4 take away y left on the inside. The highest common factor of the factors of AC are a and c, and the factors of AF is a and f. So we're getting quite abstract now. It doesn't have any numbers. So a is the common factor. So a comes out the front. We're left with c plus f on the inside. Now just think, if you expanded that, is that what you get? You'd have AC plus AF, right? If you use the highbrows on that. Alright, what's the highest common factor here? Well, 6 and 1, so highest common factor there is 1, so we're taking a 1 out, but also taking an x. So if I take an x out the front, I'm left with 6 minus a. 6 minus a. Getting complicated now. I'm looking forward. Does 6 and 5 have a common factor? So remember, just like all the other algebra we've done in previous videos, I'm always going to the numbers first. And there's no common factor of 6 and 5. P, is there a P in everything? There is. And then I've got Q and R, which are different. So the only thing I can take out, I can factorize out, is the P. So I've got P. I'll have 6Q minus 5R. And that's it, factorized. Notice how we're turning subtraction into multiplication. Really powerful, and you'll see why later on. Now, 3 terms doesn't make the problem any harder. We're just looking for a common factor all the way through. 3, 1, 1. So we can't do anything with the numbers, but there is an x in all of those. So if I had an x out the front, x times what is 3x? 3. X times what is xy? Positive y. And x times what is negative xz? And that's minus z. And there you have it. there's some harder factorization problems. Okay, what about these ones here? So we've got some squareds in here. So if I was looking at this one here, so that's 3x squared plus 5x. Well, the factors of this are 3 times x plus 5 times x. Now the common factor of both of those terms is just an x. So if I pulled an x out, what's going to be left? Well, I've got a 3x and a 5. That's my factorization there. What about this one? Well, I've got 2 times x plus, and it's a long one, 3 times x times x times x times x. That's x to the power of 4. So common factor is x and x. Oh, and I've got another x and another x. So what I'm going to be taking out of both of these is x squared. See how I'm just taking out the lowest power? So a wee trick for you. So I'm going to take out the lowest power, x squared, and I'm left with 2 plus 3x squared. Awesome. Okay, what about this problem here? Factors are, I see there's a 12 going to be in that, so I'm going to say that that's 2 times 12 times x, take away 12 times x. And so we have a common factor of 12 times x. So if I pulled that out the front, I'd have a 12x, and inside the brackets I'd have 2x. And this one is always tricky because it's all gone now. What's left over? Well, it's 1 and it's negative, so be careful there. I don't think we need to write it out in terms of factors anymore. I can see that 4 and 6 have a 2, x to the 5, x to the cubed have a factor of x cubed in common, and so what's left over when I take 2 out of 4 is 2, and I've got x squared. When I've taken an x cubed out, I've got no x cubes there, but I've taken a 2, so that'll be positive 3. And we are done. There we have it. Harder factorization, and we've gone all the way through to powers of 5 and 3. All right. For my students, I'll be assigning a little bit of work on this. Hit me up if you have any questions about that. Like that smash button.